All right, so this is the second part of our AP Physics 1 review. We'll be going over torque on this problem, and it's a 1999 FRQ. As shown above, a uniform disk is mounted in an axle and is free to rotate without friction. Okay, so this is the axis of rotation. A thin uniform rod is rigidly attached to the disk. That's this rod right here. A block is attached to the end of the rod. The properties of the rod and block are as follows. Rod, mass M, length R. Block, mass 2m, disk, radius 3, or radius r. System is held in equilibrium with a rod and angle theta naught to the vertical as shown above by a horizontal string. Okay, so that's this, of negligible mass with one end attached to disk, other to a wall. Determine the tension in the string in terms of m, theta naught, and g. Okay, so basically, okay, let's go over torque. Torque is just the force times the length or distance from axis of rotation. So in this case, we're going to be having a force going this way, and this is going to be the force from all this stuff. So I'll just say like force of system, and then this one, this force is going to be force of tension, and it's held at equilibrium, as it said somewhere here, right? Which means that the forces cancel out. So force S plus force tension is equal to 0. So force S is equal to force tension. Okay. All right, so force of tension, that's what we need to solve for. So basically that's just the same as solving for the force S, or basically the force applied by the rest of the stuff. This could be solved using torque. So like force analysis, we have torque analysis. I don't know if that's what they call it, but yeah. All right, first we're just going to be adding up the torques. Torque of the block is just going to be the force, so mg, but it's at an angle of theta naught. So it's going to be sine theta naught, and then times the length at which you're at, which is going to be times 2r. Sorry, this is 2m, and then times 2r, because that's the length from the axis of rotation. Plus, we're going to have the torque supplied by this right here, by the rod. So the center of mass of the rod is right here, and the mass of the rod is m. So we're just going to be doing m g sine theta naught, and then just times r, because that's where the force of gravity is being applied, center of mass. And it's a uniform rod. Is that what it said? Yeah, uniform rod right here. So it says. Okay. Times r, and this is going to be the torque. I'll say torque of system. And then we can, okay, yeah. Now we want to find the force being applied. So this is going to be also equal to the torque that's being applied on the disk. Disk is just going to be some other force. I will say force applied by everything. So applied force times r, and that's this torque right here, right? And this is going to be set equal to all of this. They have to be equal because this torque of the system is being applied on the disk. So thus the disk has the same torque. Okay, and then we want to isolate FA because that's what's equal to the force of tension. This is going to be torque of S divided by R, meaning we just need to divide all this by R, and we're going to get our FA. So I'm just going to rewrite this and do a lot of factoring. We could take out an mg sine theta naught, and we have 4, and then we have a 1. Oh, we could take out an r as well. Okay, I'll just put that here. We have a 4, and we have a 1. TS. Cool. Okay, and then we can divide all this by r, because we need to do that. And we're just going to get 5 mg sine theta naught is equal to FA, and this is going to be equal to the force of tension. So we just have, this is our answer.